Hello, my name is Melissa Talavera Jowdy, and along with my teammates Sarah Arredondo and Kenny McLaren, we are going to be presenting on our project, which is a twin decline realignment design for an underground mine. The Hermosa project is located in Patagonia, Arizona, about 7 miles north of the Mexican-American border. It is a lead, zinc, and silver operation that was acquired by South 32 in 2018 from Arizona Mining. The deposit is predicting 155 million tons, averaging about 3.4% zinc, 3.4% lead, and 69 grams per ton of silver. The map on the right is a site overview showing the deposits. Where you see the red star is the Taylor deposit, and where you see the blue star is the Central deposit. On this map, if you notice the red outline, this shows the patented claims. The blue outline on this map is showing unpatented claims. While doing the realignment, being aware of the vein trends and where the historic workings exist was very important. The part of our design regarding this project is to start from the northwest side of the property and make our way towards the central deposit of the map. Our statement is to design a twin decline realignment based on historic findings. Our objective is to investigate historic workings and historic records with the property and create a database for that information and propose a realignment of the decline while providing a high-level cost analysis of the financials. And now I will pass it on to Sarah so she can tell you more about the realignment design.
Thank you, Melissa. Part of the project scope, as my colleague mentioned, was to minimize interactions between the realignment design and the existing workings that we know of. Understanding that there are some complex geologic structures in the area, we wanted to know the best route that could be given with an overall assumption that we were working with an ideal or perfect world. We assumed competent geology throughout the property, as well as ideal environmental conditions such as access to general and specialized permitting given the new design route. Reducing the interactions between workings that are known on the property was the largest component for us in the realignment process. As you can see outlined in red, the Josephine Trench historic workings cut through the upper middle part of the patented claim boundary. The design process ensured that the realignment did not interact with the Josephine Trench, January Norton, or Hardshell Legacy mine workings as we trended our design from the northwest side of the property towards the northeast. As I mentioned previously, our design took into account historic mine workings that are known and have been mapped and digitized for the use of the technical team. However, we understand that not all workings have been accounted for given the lack of mapping that sometimes occurred in the 19th and 20th century. To handle the potential for interaction with unexpected mine workings and voids, the team created a high-level risk register that offered guidance if interactions were to occur. The risk register is broken up into three main categories: low, intermediate, and high interaction risks. These risks are then categorized by severity based on the impact to health and safety of mine personnel, environmental effects, and overall production stalling. A low interaction risk assumes that the situation would be able to be resolved by the end of shift or the end of the week. The plan of action for this level was the recommendation of a self-fill slurry that works best with small voids in unusual shapes, given that it takes shape of the environment that it goes into. An intermediate interaction consisted of a more moderate approach which could be resolved within 2 weeks to 1 month. The plan reference for this risk level was to utilize cemented rock fill, or CRF, to stabilize the void. While this approach can include interaction mitigation that ranges to a month in length, it's recommended that an economic analysis be completed to value if mining through the void after plugging is appropriate or if rerouting is sufficient enough. And lastly, a high interaction risk is any interaction that will take more than 1 month to resolve. Due to the impacts that this can have on advancement rates, it's recommended to simply use CRF and reroute. In addition to mitigation for interactions, the team recommended utilizing a MapTech SR3 laser scanner. The MapTech scanner is able to attach to the end of a boom and provides a 130-degree vertical and 360-degree horizontal view. This way, during probe drilling, technical staff is able to not only collect data regarding voids that may not have been previously mapped, but they're able to use that information if a reroute is needed.
Hello, my name is Kenny McLaren, and I will be going over the design portion of this project. To reiterate, the purpose of our design was to create a route from the current construction headings to the bottom of the silver oxide deposit at South 32's Hermosa property. This decline would allow them to further explore the silver oxide deposit's limits and create a mine plan to determine whether it would be feasible to mine the deposit or not. So in our decline, we decided on a length of the decline, a spiral, and then another length of the decline. You can see a top-down view of the spiral in the drawing on this slide. The spiral itself has a 348-foot radius, has a length of 2,410 feet, and it will take 2 passes through the spiral to get down to the proper depth. The total decline has 12,344 feet in length, a total depth of 987 feet, and 6.28 million cubic feet of volume.
Utilizing the rate of 460 feet of advancement per month taken from
This concludes the South 32 Senior Design Project. If you have any questions, please feel free to ask. You can send them to me over email at k.mcl@aol.com, and I'll try to respond as quickly as possible. Please stay safe out there.